Now let's see, again, I'm closing this communication. I'm clearing all the filters. Before that, let's say we open any browser. We'll start the communication on now let's say I'm trying to open a particular website. Okay, and I have got some particular packets which are captured in the Wireshark. Now we'll try to see whether any three-way handshake has happened and what kind of packets that we actually got. So let me filter out with only TCP here. Okay, because I have started the browser itself, there is a lot of communication that is already flowing. Okay, let me start the communication again. Okay, or else I'll try to do one thing. I'll try to filter with respect to the IP addresses to be more precise. So this is how we can filter with respect to the IP address in the Wireshark. We can give the command as ip.addr and the IP address can be specified. We have to give double equal to so that a particular IP can be filtered out of all this transaction. Okay, now when we actually filtered with respect to the particular IP, now we can see a full three-way handshake has happened between these particular two systems. So let me start with the particular packet here, where I'll also try to come with the starting of this packet. Now you can see the Ethernet is pointing to its upper layer IP4, the IP version 4 here. And again, there is a followed by IP header. Again, there is no don't fragment is set to 1 as we discussed in the previous thing. Now again, this protocol that is pointing to from this particular packet is 6. That means it is pointing to a TCP protocol. Now here we have this TCP protocol with us. Now we can see here the source port of this particular system is a random port because let's say I'm trying to access a website. Usually the websites are hosted on port numbers 80 and 443. So this will be my destination port number. Now, whenever we talk about the source port number, I can pick up any of the random ports out of the ports that are registered. So let's say I'm starting the communication of 10575. Now, in this case, we have to understand this. My IP address of my system is let's say 192.168.43.241. Now, for this to understand or the kind of communications that are established on this particular 241. So the combination of this port is also used. This is where we call it as a socket. So the combination of IP as well as the port number, this both combination of the socket will be used to differentiate, because as we have seen in one of the tab I have opened Google and another tab I have opened Gmail, and there may be a lot of applications that are continued in the background. So to differentiate all these kind of applications, we usually use this socket to actually differentiate the behavior. Okay, so similarly the destination will also be sent. There may be a lot of services on the same destination also. So accordingly the destination port number as well as the IP address can also be used as a socket. Okay, so in the TCP field we have the source port and the destination port, and we can observe the sequence number because as this is the first packet, so the sequence number is 0 here. Okay, so because as I'm initiating the connection, it will be 0. Now there will be no acknowledgement number for this because if you can see in the flags, so this is where the flags are important. If you see in the flags, out of all these 6 flags, our SYN flag is set to 1. And for this SYN flag, we have a sequence number of 0. So this is my first packet in this communication, and rest of the things are all the relevant data that is there in the protocol. Now, as we discussed, the first packet will be the SYN. The second will be the acknowledgement from the server. Now we'll go move on to the second packet. Now here we can observe it is a SYN plus acknowledgement. Now the same part. Now you can observe the source port has been changed because this is the source port, which is we are getting a reply from the server. So this is the source port of the server, and this is the destination port of the client. Okay. So this will be the destination port, and now here we can observe the sequence number is again 0. This is the sequence number of the server, but in the acknowledgement, we are getting it as 1. This 1 will be the increment to the previous 0, which is sent by the client. Now in the flags also, we can observe here both SYN as well as acknowledgement, both are set to 1. That means it is a packet which contains both SYN, the sequence number of the server, as well as the acknowledgement number of the previous SYN of the client. So it is SYN plus acknowledgement. Now we'll move on to the last acknowledgement, because we have sent an initial SYN packet. We have received SYN plus acknowledgement from the server. Now we have to send the acknowledgement to the server. Now again, we can observe here this sequence number. Now this will be the sequence number or the acknowledgement of the previous communication, and this will be the acknowledgement to the previous communication of SYN to the server. Okay, so now it has become 1, and we can observe that the acknowledgement is the flag is set to 1, right? So none of the flags are set to 1, all are zeros except the acknowledgement. Now this is the last packet in the three-way handshake. So this is how a three-way handshake is established between the client and the server. Then we can observe that the actual communication is flowing between the client and server. So there is again a data with respect to SSL communication, and again there may be different kind of packets for every push. There will be acknowledgement for all the data. So continuous data will be there with respect to that. So before this data has been started, we have to make sure that the three-way handshake is established with respect to the communication. So this is how the three-way handshake will be helpful for this connection oriented, and to help the client and the server or both the parties to start the communication. And also before that, there are some more commands to actually understand this, the open ports that are available on the system. Now, when we open the command prompt in Windows, or if we go to terminal on any Linux box, then we can use this command called netstat, where this gives the network statistics or the kind of services that are open on a system. So we can give netstat space -an. Now here we can see these are all the kind of services that are open. Now, as we discussed, so this particular thing is called a socket. Okay, so IP address associated with a port number. Let's say this is 192.168.43 or 241. That is associated with a port number of 131. Now this is a particular socket. Or let's say I'm trying to browse some of the websites here, and we can see there are also connection states with respect to TCP. So for every connection, let's say a SYN is sent, then we can say the connection is in the state of the connection is in the initial phase. Or after this entire three-way handshake is completed, we can see the status as established. Or if it is, let's say the server is listening for the any type of connection, then it is in the listening mode. Or let's say there is already certain connection established, but it is waiting for certain commands or kind of thing, then we can go for the time wait. And there may be some states where the connection has been established, or a first level of FIN closing is already done, then it is waiting for the complete closure of the connection. So these kind of states are also used, because these states are used in the security devices or in the perimeter level devices to actually decide the type of connection, and based on that the behavior or the kind of rules can be written onto. Okay, so this is how now you can see my IP address is same in all the communications. Okay, my IP address doesn't change in all the communication. There may be a lot of destinations I'm talking to, but you can observe even though my IP address is same, the port numbers are varying in all these communications. So that are connected to all these different machines outside my network, or from where I'm trying to get the connection. So this is how the entire socket will be used to multiplex or demultiplex the connections using the transport layer protocol. Okay. So again, there are certain vulnerabilities again associated with TCP, as we have with other protocols also. Like there are no access controls with respect to the TCP, and the TCP headers can be manipulated, because we can some of the tools we can generate our own kind of headers with respect to TCP, or the packets can be generated so for manipulation. And we have TCP packets which can also reveal certain OS details based on the window size. As we have discussed, there is a parameter of window size in the TCP protocol, where a window size can be decided to actually decide what kind of or how much throughput can be put into the packet. So that kind of parameters will also reveal the OS details with respect to the TCP. And even the TCP states can be exploited. That is where we'll have some session on the security devices, because now let's say instead of synchronous packet, directly I'm sending an acknowledgement packet to the destination. Now in this kind of scenario, what the destination has to respond, because there is no establishment of the connection, but there is a direct acknowledgement to the service on the destination. So these kind of states can also be exploited, where certain security devices will also look into these states which you have seen in the previous window, right, or the command prompt. So, and even some of the protocols, if they are clear text protocols, we can use the traffic that can be captured. Even a normal kind of, let's say this is an SSL traffic, but if it is a clear text traffic, now let's say in the Wireshark, when you click on a particular packet and there is an option called follow. So in this follow, you can click on any of the stream according to the protocol. If I click on TCP stream, now this is the actual data that is flowing, but the packet which you are which we are viewing in this particular scenario is an SSL or the TLS encryption. That is where we cannot see what is the traffic that is flowing on. But let's say if it is a clear text protocol like a telnet or any kind of protocol, then it is very easy for the even for the packet capturing kind of things to easily see the data that is contained inside the packet, because it is a clear text protocol. So that is where we cannot avoid these kind of vulnerabilities that are associated.